Hello everyone. Now I am going to discuss about microwave oven simulation which was given by the MTech internship based on the embedded system subject. So this project is done as a team. My team member is Kuruba Srinivasulu and myself Tejishwar Kamarthi. We are studying BTech final year from the Department of ECE in Sri Vidyaniketan Engineering College, Tirupati, Andhra Pradesh. So let us start the session. So, this PPT consists of topic learns from the C language, embedded systems, overview of project, what is microwave oven, project requirements, project implementation. Let us see one by one. So, the topics learned from the C language are introduction to C, data types means integer data type, character data type, float data type, etc. Data modifiers and qualifiers, data representations. And conditional statements. What are conditional statements? First, we have to know about what is C. C is a general purpose programming language created by Dennis Ritchie at the Bell Laboratories in 1972. It is a very popular language despite being old. The main reason for its popularity is because it is a fundamental language in the field of computer science. So next, conditional statements. Conditional statements is used to specify a block of code to be executed if a specified condition is true or not. So if it is false, the else statement will be printed. And next, about loops. Loops are used to execute the block of code several times according to the condition given in the loop. It means it executes the same code multiple times. So it saves code and also helps to traverse the elements of an array. So next, operators. Operators are arithmetic operators, logical operators, and relational operators. So these are the different types of operators where we can perform the operation between the two operands or two or more operands. And next, arrays. So an array is defined as the collection of similar type of data items stored at contiguous memory locations. Arrays are the derived data types in C programming language which can store the primitive type of data such as integer data type, character data type, double data type, etc. And strings are represented in the double quotes. And let us know about the functions. Functions in C are the basic building blocks of a C program. A function is a set of statements enclosed within curly brackets that take inputs, do the computation, provide the resultant output. You can call the function multiple times, thereby allowing reusability and modularity in C programming. And next, about pointers. Pointer is defined as a derived data type that can store the address of the other C variables or a memory location. And next topic is variables and storage classes, and macros and preprocessors are the topics which we learned from the C language. And next slide is embedded system. What is embedded system? Embedded system is combination of any hardware and software which is intended to do a specific task. A general purpose system is used to perform large number of tasks. In an embedded system is used to perform a specific task. Here are the some examples for the embedded system. Microwave oven, washing machine, TV, cameras, refrigerator, mobile phones, airbags in cars. These are the examples for the embedded system. And there are different categories of embedded system. Those are standalone embedded system, real-time, networked, mobile. So these are the four types of the embedded system. So next slide is. So what are the requirements for the embedded system? Reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. So these are the requirements for the embedded system. And what are the challenges faced in the embedded system? Efficient inputs and outputs, embedding an OS, code optimization, testing and debugging are the challenges faced in the embedded system. And next slide is, so components of the embedded system. You can see the flow chart of the components of the embedded system as shown in the slide. You can see actuators, digital to analog converter, sensors, auxiliary system, A to D converter, human interfaces, microcontroller or system or chip or microprocessor, diagnostic port, FPGA or ASIC, memory unit. So what is actuator? An actuator is a device that produces a motion by converting energy and signals going into the system. The motion it produces can be either rotary or linear. An actuator is a device that produces a motion by converting energy and signals going into the system. So what is digital to analog converter? So first of all, knowing about the D to A converter, we have to know about the A to D converter. As this computer cannot understand the analog data, so we have to convert the analog data into the digital data. Digital data means in the binary form like zeros and ones. So we have to convert the analog data into digital data by using A to D converter. As human cannot understand the digital data, we have to convert the digital data into the analog data. So we are going to use the digital to analog converter. And the sensor block, and sensors means used to sense the temperature, humidity in the environment. So these are the different types of sensor used in the embedded system. And the auxiliary system is used for power cooling and a human interface diagnostic port. So these are the components of the embedded system. And whereas the memory unit, RAM, ROM are the basic building blocks of the memory unit. So this is the components of embedded systems. So next topic. So difference between the microcontrollers and microprocessors. So microprocessor is the heart of computer system, whereas microcontroller is the heart of embedded system. It is just a processor, memory and input output components have to be connected externally in the microprocessor. Whereas microcontroller has external processor along with the internal memory and input output components. Since memory and input output components has to be connected externally, the circuit becomes large in the microprocessor. Whereas since memory and input output components are present internally, the circuit is small in the microcontroller. Microprocessors cannot be used in the compact system, hence it is inefficient. Microcontroller can be used in the compact system and hence it is an efficient technique. The cost of the entire system increases in the microprocessor, whereas the cost of entire system is low in the microcontroller. Due to external components, the entire power consumption is high. Hence, it is not suitable to use with the device running on storage power like batteries in the microprocessor. Since external components are low, total power consumption is less and can be used with the devices running on the stored power like batteries in the microcontrollers. Most of the microprocessors do not have power saving features, whereas the microcontrollers have power saving modes like idle mode and power saving mode. This helps to reduce power consumption even further. Since memory and input output components are all are external, each instruction will need external operation. Hence, it is relatively slower in the microprocessor. Whereas coming to the microcontroller, components are internal. Most of the operations are internal instructions. Hence, speed is fast. Microprocessors have less number of registers, hence more operations are memory based. Whereas microcontroller have more number of registers, hence the programs are easier to write. Microprocessors are based on the von Neumann architecture, where program and data are stored in same memory module. Sorry. Microcontrollers are based on the Harvard architecture, where program memory and data memory are separate. Microprocessors are mainly used in the personal computers like laptops, desktop, used in the offices and labs. And microcontrollers are used mainly in washing machine, MP3 players. So these are used in the embedded systems. And next topic. So microcontrollers. So in our project we are going to use the PIC16F877M microcontroller. So there are some terms to implement our project. So let me discuss by one. A system which is used to develop the target is called host. In our project, desktop PIC16F877A microcontroller is used as host. And a system is which is being developed for a specific application is called target. Here we use the microwave oven as our target in our project. Now cross compiler, an application used to generate code for another architecture being in another architecture is called cross compiler. Here we use the MPLAB XID in our project. There are different versions available from the online. Those are free of cost. I am going to use MPLAB XID v5.35 version in my project as said in the internship. So next topic is overview of the project. Microwave oven is the project which is implemented on the PIC controller. It has different modes of the cooking such as grill, micro, convection and start modes. As per the user requirement, the user can choose whichever mode of cooking he wants to use. Our objective to implement all the modes and functionality of a microwave oven on the PIC16F877A board is using and test it on simulating on the PIC SimLab software. The code is written in the embedded C. And next topic is, so what is microwave oven? Microwave oven is used to heat the food using microwaves which is of form EM waves. EM waves means electromagnetic waves. There are several modes in various microwave oven. So we are going to implement four modes. Those are micro mode, grill mode, convection mode and start mode. Let us discuss these modes one by one in coming next slides. So micro mode. It uses maximum power of 900 watts. This mode is used to cook in a traditional way. In this, the maximum time you set for cooking is 60 minutes. So this is about the micro mode. And next coming to grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. User can set time as per the cooking time of meat. And next third mode is convectional mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After preheating it done, then the user can set the time as per the requirement. And the last mode, start mode. Start here we can use the options start and resume and pause option and stop option. Let me discuss these four modes again in the project implementation. So next slide is, so what are the requirements for doing our project? So one should be good enough in the embedded C. So knowledge in embedded C, and we have MPLab XCID software, XC8 compiler. So these are available from the online with free of cost. And next is PICSIMLab. It contains PIC16F877 microcontroller, CLCD 16:4 display, tactical switch, matrix keypad, timer 2, ISR. So these are the components in the PICSIMLab. So let us discuss one by one. So you can see in this slide, right, this is the image of the PIC16F877 microcontroller board. Here where we can see the fan, buzzer, LEDs, 7 segment display, 16:2 crystal display, and this is the microcontroller. These are the relays, reset button, push button. These are the LEDs, matrix keypad, serial port. Yes, right. So next slide is CLCD 16:4 display. CLCD stands for character liquid crystal display. So a 16:4 character liquid crystal display is a type of display module commonly used for presenting textual information in various electronic devices. It is characterized by its ability to display 16 characters per row and 4 rows of characters, resulting in a total display area of 16 columns by 4 rows. Here we can see the image of 16:4 display. You can see this, right, 16 characters for 4 rows. So these are the functions of CLCD 16:4 display. So 16:2 display is also available in our PICSIMLab. So but in our project we are going to use 16:4 display. So coming to next topic, tactical switch. So this is the image of tactical switch. A tactical switch is one type of widely used switch that completes an electrical circuit typically when pressure is applied to the device by the user, which then gives the user a perceptible click or haptic bump in response indicating current flow. Current flow is turned off when the switch is released. To give a shorter definition, a tactical switch is a momentary action device whose operation is perceptible by touch. This tangible feedback gives some assurance to the user that the switch has operated and signal has flowed. Tactical switch models are also available that turns off current when the switch is pushed and turn it back on when released. So these switches are available from CUI devices. And next topic is matrix keypad. So you can see the image of the matrix keypad. This image is 4:4 matrix. You can see the switches, right? These switches are connected by the wires. Matrix keypad is a common input device used in the various electronic systems and devices such as calculators, remote controllers, security systems, and industrial control panels. It is designed to provide a convenient way for user to enter numerical or alphanumeric data and commands. So there are different functions in the matrix keypad. Those are scanning, button press, key detection, key debouncing, determining the press key. So these are the functions of matrix keypad and the applications. Consumer electronics, security system, industrial control panels, embedded systems are the different applications for the matrix keypad. And next topic, timer 2 module. The third and last timer module of the PIC16F877A is the timer 2 module. This module is originated to work along with the pulse width modulation module of the PIC. It can be used of course as a timer as well. It is an 8-bit counter and has a programmable prescaler and postscaler. It has only one interrupt source, an internal instruction clock, that is device oscillator frequency by 4. Timer 2 module is equipped also with a period register. Here we can see the block diagram of timer 2 of general PIC microcontroller. You can see the prescaler block diagram, timer 2, that is 8-bit register, and this is postscaler where we can use as the postscaler, and this is the comparator. So this is the block diagram of timer 2 of PIC microcontroller. And next topic is ISR. ISR stands for Interrupt Service Routine. It is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it. It executes the handling and then returns a logical interrupt value. If no further handling is required, the ISR notifies the kernel with the return value. An ISR must perform very quickly to avoid slowing down the operation of the devices and the operation of low priority ISRs. Although an ISR might move data from a CPU register or a hardware port into a memory buffer, in general, it relies on a dedicated interrupt thread or task called the interrupt service thread to do most of the required processing. If additional processing is required, the ASR returns a logical interrupt value to the kernel. It then maps a physical interrupt number to a logical interrupt value. For example, the keyboard might be associated with the hardware interrupt 4 on a device and the hardware interrupt 15 on another device. The ASR translates the hardware specific value to the standard value corresponding to the specific values. So these are the requirements for doing the project on the Pixim lab. So coming to the project implementation, let us see the project implementation. So this is the Pixim lab available from online source. We can download it from the online with free of cost. So we have to select the board as Pic Genius. So wait, it is loading. And next we have to choose the microcontroller, that is PIC16F877A microcontroller. So we have to select the clock frequency as 20 megahertz and the LCD display as 16:4 LCD display, and we have to load the exa file into it. So here you can see the exa file we have to load on the Pixim lab. So you can see that powering on microwave oven, and these are the 4 modes as we earlier discussed in the PPT. And by pressing 1 we can start the micro mode. So here you can see that the power required for microwave oven is 900 watts, and we have to enter the time for micro mode. So now I am giving 5 seconds. So you can see that here 5 seconds. So press enter. So fan is rotating, right? The time is running. You can listen the buzzer sound, right? You can listen the buzzer sound, right? So for second mode, grill mode, we have to set the time for 5 seconds. Enter. So fan is running. So you can listen the buzzer sound, right? Cooking time up. So for convection mode, please enter third option. You can enter the temperature. So I am entering 50 degrees Celsius. So please enter. So you can see that, right, preheating time is remaining 50 seconds, 46. So let us wait for 40 seconds. So as earlier discussed, this is the fan, heater and buzzer, and here we can see the temperature is 27.50 degrees Celsius, and this is the clock frequency, and this is the matrix keypad, and these are the tactical switches, and these are the LEDs. 7 segment display. This is so after completing the preheating, we have to enter the time for the heating procedure in the conventional mode. So as we know that earlierly in the grill mode as micro mode, we can give the time as per our requirement. After entering the time, please enter, and after time up, the buzzer sound will blow in the conventional mode. So last mode is start mode. So here we can see the start mode by pressing 4. So here we can see 30 seconds the fan is rotating. So by again clicking option 4, you can see that 30 seconds added more. So we can pause the option by clicking the button 5. You can see that time is paused, fan is stopped. So again we have to resume, we have to click the button 4. So you can see that right, the time is resumed, the fan is rotating. So for stop mode we can click the button 6. So it is stopped, right, fan is stopped. So this is about my project which was given by the MTech internship. So thank you everyone.